All right, this is our next video in our work with quadratic functions, and specifically today we will be looking at graphing quadratic functions using what I call vertex form, with an introduction and then a couple examples. Okay, so vertex form is as follows: y equals a times the quantity x minus h squared plus k. And in a prior video, you're probably familiar with h and k. Those are the coordinates of the vertex. And you've also worked with a. That's the coordinate of the x squared piece in standard form. It's the same a. And that still tells us if our parabola has been stretched vertically or compressed vertically, and if it may have been vertically reflected if a is less than 0. What you're not seeing here are b and c. Okay, so b was that complicated coefficient that can translate our parabola left, down, and up and right. And c was the very nice and simple coefficient that just told us the y-intercept. So it's hard to get the y-intercept from vertex form. But what we do get from vertex form really easily is the vertex. So the vertex, again, is at h comma k. And that's just my notation. I write the big V meaning vertex, and then h comma k implying that those are the coordinates of the vertex. So let's graph a quick parabola here, a quick arbitrary parabola, just so you can see this visually. And this point right here is my vertex with the coordinates h comma k. Okay. This is still our c value, but it doesn't show up in our y-intercept, doesn't show up in vertex form equation. Okay. All right, so let's do some examples at graphing. Okay, so we will be using vertex form. And I think maybe as we're going through this, do some thinking about what are the pros and cons or advantages or disadvantages of vertex form versus standard form. Vertex form obviously gets you the vertex really cleanly and easily, but it doesn't get you the y-intercept. So do some more thinking on that, and maybe do some thinking about which one you prefer. So the common mistake or confusion here is thinking that the h coefficient of our vertex, or our h coordinate of our vertex, is 1. Okay, I want you to remember that vertex form always has a subtraction inside those parentheses. Okay, so what are we subtracting? We're subtracting a -1. Okay, this says x plus 1. That's the same as x minus a -1. So we need to think of our vertex as having the coordinates of -1 comma -4. All right, so we can plot that up. Let's have just a normal scale. 1, 2, 3, 4. So that's our vertex right there. Now we don't have an easy y-intercept to plot. Okay, but we do need more points to plot. And we can always use symmetry to plot points. So I'd like to think about what are some easy numbers to plug in. It's easy to plug in 0, and that will get us the y-intercept. It's easy to plug in positive numbers as well. So how about we don't plug in numbers to the left of the vertex, but instead we plug in some numbers to the right of the vertex, and then use our symmetry to get those points over there. All right. So let's plug in 0. So let's find f of 0 is 2 times 0 plus 1 squared minus 4, which equals -2. Okay, so when x is 0, y, or f of 0, is -2. And then let's use symmetry to get that as well. Let's find f of 1. That's 2 times 1 plus 1 squared minus 4. So that is going to be 4. So f of 1 is 4. 1, 2, 3, 4. Use symmetry to get that as well. So it looks like we have a pretty solid parabola that we can go ahead and graph. And we got this using vertex form. Our vertex is -1 comma -4. All right, moving on to the next one. We have another example with vertex form. And what I want you to realize here is our a value isn't totally written out, but a is -1. Okay? But I hope you can see that our vertex is 2, 3. Okay, remember inside those parentheses we're subtracting a positive 2, so our vertex is positive 2. So let's graph that in. Let's have a normal scale. So that's our vertex right there, 2, 3. And it looks like our parabola is opening downwards, so we need to plug in some other points. So we can find f of 0. Let's find f of 1. Again, plug in easy points. Why not, right? F of 0 is negative 0 minus 2 quantity squared plus 3, which is going to be negative 4 plus 3, negative 1. Okay, so we have that point right there. We can use some symmetry to get that point over there. F of 1, negative 1 minus 2 quantity squared plus 3. That's negative 1 plus 3 is 2. Okay, and we have those two symmetric points right there. We can sketch in a curve. Really want you to try to, when you're sketching in your curve, don't just connect the points with a straight line. Don't do this. Don't do straight line, straight line, straight line. That's not a parabola. That's just a bunch of straight lines, okay? So really try to sketch in a smooth curve. And let's make sure we had it written down. What was this? This was a 2. Okay, cool. And then the last couple examples we'll do in this video are converting to and from vertex form to standard form, okay? So it looks like in our left-hand example, we have something in standard form and we have to find vertex form. And we're going the opposite direction in the right-hand example. So if you have it in standard form and you want to find vertex form, let's find the vertex. Okay, so h, let's find h first, is negative b over 2a, whoops, which is 4 over 4, which is 1. So h is a 1 here. And remember, we're looking for our vertex, which is h comma k. Let's find k. We're going to plug in 1 in for x. So we're going to find f of 1. 2 times 1 squared minus 4 times 1 minus 3. We're just plugging into our equation. So that's 2 minus 4 minus 3, which is negative 5. So that's k. All right, so we have our vertex is at 1 comma negative 5. And we also know what a is. A is 2, and I just pulled that straight from the equation right here. So let's write out our vertex form. Y equals our a value times x minus our h value squared plus our k value. Okay, so these two equations represent, they look different, but they represent identical parabolas. Okay, and so the way we did that was by finding the vertex and then just plugging our numbers that we got into our vertex form equation. Let's go the other direction. Okay, so for this one over here on the right, we are going to take vertex form and turn it into standard form. And the way we do that, we are going to first FOIL. So we are going to square that x plus 1. Then we will distribute the 3 and then subtract 5. So we're just following our rules of multiplying binomials. 3 times, this is x squared plus 2x plus 1. I did that a little bit quicker there, but I did first, outer, inner, last, or double distribution to get the product of those two binomials. I am going to then distribute the 3 all the way through and get y equal 3x squared plus 6x plus 3. And then we have a minus 5. And lastly, I'm going to combine some like terms. 3x squared plus 6x minus 2. All right, so again, just to be clear, this parabola and this parabola are the same. The equations are just in different forms, but they both represent identical parabolas. All right, and that's a good place to stop.